Hello class, we will be talking about more triangle proofs. Let us try to get started with the first question here. So I'm going to use the red to mark the givens. HL has to be congruent to HG. So AH has to be congruent to AG right here. All right, and then HB has to be congruent to GB. Now, as soon as we have done this one, we get to realize that, hey, wait a minute. It looks like this triangle contains two line segments that might be useful to prove to be congruent to the other pair. So having that in our minds, let us try to continue to see what happens. Ultimately, what we need to prove is HE, which is this line segment, and then GE, which is this line segment. As you notice that these two are not the part of the original triangles that which we mentioned. In other words, what we need to do is we probably have to prove the triangle AHB must be congruent to AGB. Now, given that using the corresponding parts being congruent to each other, using that idea, we should be able to somehow prove that these two green line segments must be equal to each other. So let us try to look into this example together, see what happens. So, first, I'm going to draw the line. So this will be the reasoning, and this will be the statement. So first one, I'm going to assume that these are all in here as the givens. Number two. Now, but we get to realize that here in the middle, line segment AB must be congruent to each other, either reflexive. So I'm going to write down AB must be congruent to AB. And number two would be reflexive. Now number three, then using the reflexive property because of SSS, so as SSS, we get to prove that first triangle HB must be congruent to triangle AGB. And the reasoning here must be SSS. Now, given that in order for us to try to go for this line segment, you see HB, we can use that one more time for the smaller triangle, if you wanted to prove that this triangle is congruent to this one. And then one more thing that we get to realize is EB is congruent to itself. So why don't I write down this portion? EB must be congruent to itself. And that will be reflexive once again. Number five. Now, the next one is we have two conditions so far, side and another side. We cannot use HE nor GE because those are the line segments which we need to prove them to be congruent. Then another thing which we could have done was the angle. You see the angle right over here. These two angles are congruent by, yes, corresponding parts being congruent to each other. So we can say angle HBE must be congruent to angle GBE. The reasoning here must be yes. CP, CT, C. Corresponding parts in congruent triangles are congruent. Number six, because of that, we can say triangle HBE must be congruent to triangle GBE. Once again, it would be side, angle, and side. Number seven. Since these two triangles are congruent, then we can finally say HE must be congruent to GE. And the reasoning must be CP, CT, C. All right, there it goes. Let's go for the second question together. Here we have, which is somewhat similar to the first picture, we have overlapping kind of idea here. Now, so once you let us try to mark the givens here, TR, which is this entire line segment, is congruent to TS, which is another entire line segment, or side of the triangles. And NR, which is the bottom portion, is congruent to NS, which is also another bottom portion. Now, ultimately, what we need to prove was the line segment RN, which means this line segment must be congruent to MS, which is this line segment. All right, so which two triangles would you like to prove them to be congruent? Yes, there are many ways for us to do it, but among many, one way which we could have done was, if you think about it carefully, maybe we can try to go for this triangle, T, R, N, because Rn is the part of that triangle. Now, the next question is, do we have enough pieces of information for us to prove that that triangle is congruent to each corresponding part? You see, one thing which we can reason out is this: since TR is congruent to TS, so is MR and MS. If we have to subtract those two, then remainders must be also equal to each other. And of course, we cannot forget that angle T is common in both. That means side angle, side. Side angle, side. Right over here. So therefore, we are looking at those two triangles that I originally mentioned must be congruent to each other. Hence, using CP, CTC, we should be able to prove the last statement. So then let's try to get started. So first, we're going to write down regions right over here and statement. Once again, we're going to assume that all these things are right over here. And then the reasoning will be givens. Number 2. Now, after we have done that, what we have done was Tm is congruent to Tn. And the reasoning was the subtraction postulate. Now, next one was angle T was congruent to angle T. That was the reflexive. Now, statement number 4, therefore, we could have actually said that triangle TRN must be congruent to triangle TSN. Now, statement number 4 is based upon side, angle, side. Then when you look at number 5, then we can say RN must be congruent to MS. And the reasoning behind that will be simply CP, CT, C. All right, let us move on to number 3. Here we have angle 3 is congruent to angle 4. So this angle is congruent to this angle. All right, and then angle ABC, which is ABC, the entire angle is congruent to DCB, which is the other entire angle. You see, as soon as we realize that, we can reason out also that this angle must be congruent to this angle by the subtraction postulate. Then somehow the question is, can we prove that the angle 5 and angle 6 are congruent to each other? In fact, we'll try to do this one in a bit interesting way. Because which two triangles would you like to prove them to be congruent? That's my question that I want you to think about it just a little bit. That's right. Yeah, in fact, you can prove that angle 5 is congruent to angle 6 by having this line segment BC reflexive. And then I'm looking at the triangle ABC. You see that in this case, we talked about this side, and we are looking at the entire angle ABC must be congruent to the other one, so angle. And then the small angle right here, number 2, by the subtraction postulate. So angle, side angle. There it goes. Now, then let's write it up together. Statement and the region here. First, we're going to assume to bring all these things together up here. And the reasoning will be the given. Number 2. Then by the givens, another thing which we realized was angle 1 was congruent to angle 2, which was subtraction postulate. Now number 3, next thing was, yes, BC was congruent to BC. And then the reasoning was reflexive. Number 4, therefore we could have said triangle ABC must be congruent to triangle DBC. And statement number 4 was angle, side angle. Now number 5, then we get to realize yes, angle 5 must be congruent to angle 6. Why? Yes, simple reasoning of CP, CT, C. All right. So with that, we finished up to number 3. Let's go for number 4 together. Here we have, if you have to mark the givens, SJ is perpendicular to PR. Then we realize the right angle over there. So it's TS, and then RQ, and then another right angle right over there. And J is the midpoint of PQ, so that means we're looking at this line segment, which congruent to that line segment. And then RP, which means this whole angle at the whole side, is congruent to this whole side, RQ. Now, then ultimately, using all those things, how can we prove that SJ, which is this line segment, is congruent to JT, which is this one? You see, as long as we could, as long as if we can focus on those two congruent line segments, we should be able to do this one in a couple of different ways. But one thing that which we like to do might have been something like this. Since these two sides are congruent, the triangle PRQ is an isosceles. That means these two angles must be, the two base angles opposite congruent sides must be congruent. Some people could call that a space angle theorem. Now, then all of a sudden you get to realize that the other side is also right angle. So angle, angle, side, angle, angle, side. Therefore, these two triangles are congruent, which makes the bottom portion congruent. But let's see which direction this one is leading us. And then PSJ. PSJ. Those are congruent to each other. Why? Because perpendicular, even though many times we write this one in two different steps, in this example they used it as one. That's perfectly fine also. Perpendicular lines form congruent right angles. Even though we put this one in two different statements, right angle and then congruent, but we can simply put them together. The midpoint of the segment is a point that divides the segment into two congruent segments. So that therefore this basically meant the PJ must be congruent to QJ. And then RP is congruent to RQ that was given. Therefore, angle P and angle QR. Once again, this one, personally, what we like to do is separate this one into two different statements, making the triangle PRQ as an isosceles triangle first. But we can try to write this one up together in this way. In a triangle, two angles from congruent sides are congruent, simply put. Now, then those two triangles are congruent by, as we mentioned earlier, angle side, and which gives us SJ, and then JT would be CP, CT, CP. All right, so that was number 4. Let us move on to number 5. This is very classic and a very interesting question. Triangle ABC is an equilateral triangle. Now, that means we realize that AC is congruent to CB, which is congruent to BA. Not only that, angle ABC individually, their angles are also congruent to each other. But second thing is CT, which is this line segment, also is congruent to AR, and so is SB. Then you get to reason out that the other pairs also must be congruent by subtraction postulate. Now, but since all the angles are equal because equilateral triangle, then that implies equiangular. Now, that means these three surrounding triangles are congruent to each other. Then interestingly, what's going to be happening is that they will say this line segment SR, so as ST or TR are they all congruent to each other by CP, Then I think our game is over already then, because then that by definition that is an equilateral triangle. So let's try to get started. So first, we're going to bring this one over here. And then we're going to write down given. Then number 2. Number 2 is, then we can say AC must be congruent to BC, which is also congruent to AB. Because an equilateral triangle has 3 congruent sides. Or we can say definition of an equilateral triangle. Either way is fine. And so that's what we end up getting. Now, statement number 3, we get to realize that because CT is smaller pieces are congruent, we get to realize that AT, which is congruent to CS, which is also congruent to BR. Why? By the subtraction postulate. Now, number 4. Angle A is congruent to angle B, which is congruent to angle C. Why? Number 4. Equilateral I can say simply equilateral triangle R, or triangles are equiangular. So therefore angle ABC are all congruent. This allows us to say triangle ATR must be congruent to triangle CSJ CST, and which is also congruent to triangle BRS. Now, the reasoning, all because of the angle, side angle. That leads us to say line segment RT must be congruent to TS, which is also congruent to SR, or RT. Oh, actually, SR, because we already talked about RT, yes. My bad. So SR. Now, number 5 would be, yes, the big CP, CTC for all three triangles. Alright, so with this one, we are finishing up part 1 of the review. We're going to continue with part 2 and part 3. Enjoy! See you guys later.